Hey Ramblers! This video covers chapter 12.4 in our textbook and deals with the volumes of prisms and cylinders. As we noted before, prisms and cylinders are very similar because they both have two parallel bases, and so many of the formulas that apply for prisms also work for cylinders, as we'll see again with volume tonight. Now I'd like you also, after the video, to know what volume is and how it's different than area. So we'll go through the definition of volume. But then I want you to know the formula for how to find the volume of a prism and how to find the volume of a cylinder, and then understand what a cross-section is. And finally, how could we use a formula involving cross-section to find the volume of a prism or a cylinder? Okay, so there's lots to do. Please take careful notes, pause often, and good luck. Thanks for watching. Okay, let's start out with our definition of what volume is. As we saw in the previous part of chapter 12, surface area is the amount of space on the outside of a figure. But volume is the number of cubic units of space that are contained by the solid. So in other words, it's the amount of space inside of a solid. Well, when we talk about a cubic unit, it's really just a cube that is 1 unit wide, 1 unit long, and 1 unit high. And the question with volume is, how many of these cubic units will fit into the larger unit? The larger, be it a prism, or a cylinder, or a pyramid, or a cone. So the trick, as I'm sure you've all been able to do since you were very young, is to multiply the length times the width times the height. And that, of course, is our volume of a rectangular prism. It is just the length times the width times the height. Of course, we can abbreviate that as LWH. But I hope you recognize that length times width is the area of the base. And length times width times height is just going to represent a simpler formula that I'd like you to memorize. Volume of a rectangular prism, or as we'll see in a moment, any kind of prism, is the area of the base times the height. Please get that in your notes. The volume of a rectangular prism is the area of the base times the height. Now let's take a look at some other types of prisms and cylinders. And here you can see a square prism. We have a triangular prism. And they're recognizable by their bases and their quadrilateral sides. Well, in a cylinder, we have, again, two parallel bases, but they're circles this time. Nevertheless, the formula for volume is going to be, for a cylinder, is the same as what we'd find for a prism. So the volume of a prism, as we said, is the area of the base times the height. That applies to any kind of a prism, be it square prism, or triangular prism, or pentagonal prism, or something like that. The volume of a cylinder will also be the area of the base times the height. Now, when we recognize that a cylinder always has a round base, then the volume of the cylinder can be written as pi r squared times h. Alright, so now you've been given the volume of a prism and the volume of a cylinder. Make sure those are in your notes in a separate sheet so that you have them separated so they're more easily memorized. All right, let's take a look then at this one last concept in this section, and that is a idea of a cross section. Now, a cross section is the intersection of a solid and a plane. Now in this book, it's almost always going to intersect the solid parallel to the plane. So here we have a triangular prism. The red plane here represents the intersection of the triangular solid with the plane, and this red part would be the cross section. Here we have a rectangular prism, and this red rectangle represents the cross section. You'll notice that the cross sections in prisms, when parallel to the base, are congruent to the base itself, which gives us yet another formula that we can use, and that is that the volume of a prism or cylinder is equal to the area of a cross-section times the height, because of course the area of a cross-section will be equal to the area of a base in a cylinder or a prism. Alright, Ramblers, please get all that in your notes. I'm going to take a look at a couple problems in the tutorial. Thanks for watching. Number 9 on page 580 asks us to find the total area and the volume of this triangular prism. So the total area can be found as we had before, but breaking it into lateral area plus the two bases. And we know that the lateral area is going to equal the perimeter of the base, which in this case is going to be 13 plus 13 plus 24, times the height. Now it's not the height of the triangular face, but the height of the prism, which is 10. And then we're going to add on the area of two bases, which is going to be 1/2 24 times the height. And if we drop an altitude in this isosceles triangle, it'll bisect the base, and so we have a 5, 12, 13 triangle. So our total area should equal 620 square units. All right, now when we look at the volume, we're going to take the area of the base, which we've just calculated, and we multiply that times the height of the prism, which is 10. So area of the base we'll take from the prior problem, and that's going to be we have 60 units times the height of 10, so the volume is going to be 600 cubic units. Okay, Ramblers, let's take a look at number 10b, because that also causes some problems. Okay, number 10b is kind of a half cylinder, and so they ask us to find the total area and the volume. And of course, total area is going to be easier to find first because we need to use the area of the base. That's part of the total area when we find the volume. So let's start there. This total area is going to equal 1/2 the LA of a cylinder, and then we're going to add on that rectangle part on the top that you see here. So let's just call it the rectangle. And then we're going to add on 1/2 times the two bases because they're two half circles. Okay, that should be everything. Well, let's now start to break this down. Well, 1/2 the lateral area of a cylinder is just going to be 1/2 the circumference, which we've seen is going to be 12 pi times 20, because that's the height, plus this rectangle, which is 12 times 20, plus 1/2 2 times the bases, which are 6 squared pi. All right, let me simplify all this. And our total area is 156 pi plus 240. Now, let's go and find the volume. Well, once again, since this is a cylinder, we're going to take 1/2 the area of the base times the height. And we're doing the 1/2 because we only have half a cylinder. So we can take the area of the base from the first part, and we know that each base is 6 squared pi, or 36 pi. So I get 1/2 36 pi times our height of 20. And when I simplify that, I get 360 pi. Okay, Ramblers, hope this helps. Thanks for watching.